Converting a mixed number into a fraction, the shorthand is multiply the whole number by the denominator and then add the numerator. So in this case, I can take 1 times 3. I can add 1. What's that going to give me? 4. And then what do I do with that 4? Yeah, I put it over the denominator. Can anybody give an argument for why? Why does that work? How come we can get away with rewriting a mixed number as a fraction in that way? Think for a moment about hidden arithmetic. So a minute ago I mentioned that there's a hidden arithmetic symbol right here in between the whole number and the fraction. What was it? What's missing there? Yeah, plus sign. So if we think about it that way, then we turn it from kind of a weird set of glyphs that communicate a quantity, we turn it into an arithmetic problem. And let's take just a moment and unpack that arithmetic problem. And we saw a problem similar to this on Wednesday of last week. If I'm going to add 1 plus 1/3, because that is what we mean by the mixed number, 1 1/3, then how do I do it? How can I add a whole number to a fraction? Rewind the tape to Wednesday. What do I want to do first? Yeah, first thing I want is I need to get these both into fractional form. Right? I don't know how to add a whole number to a fraction, but I will know how to add a fraction to a fraction, so we're going to set that as our first priority. And how do I turn a whole number into a fraction, first of all? How do I turn the number 1 into a fraction? Exactly. Any whole number we can rewrite as a fraction just using a denominator of 1. But now it raises the problem that I'm trying to add 2 fractions whose denominators are different. So what do we have to do then?
Multiply the denominators?
Yes, this was the little shorthand that we talked about on Wednesday as a quick and dirty way to always get a common denominator for a pair of 2 fractions. It may not always be the least common denominator, but it's always a common denominator that will work. It'll get the process started. And if you're a little bit anxious about fractions, it's nice to have something where you don't have to do a lot of creative thinking in order to move your arithmetic forward. That's why I kind of like this way of doing it. Just multiply the 2 denominators, 1 times 3. And that product will give me a denominator that will work in common for both fractions. Now that we know what the denominators are that we want, how do we find out what the numerators ought to be?
We do 1 times 3.
Yeah, this was the other little shorthand that we talked about last time. If we multiply the denominators to get our new common denominator, we can then, what's sometimes called cross-multiply, although I use that term very carefully, the numerator of each with the denominator of the other to get the corresponding numerators of our new fraction. So my 1 over 1 turns into 3 over 3. And what about the other one?
Multiply the 1 and 1.
Yep, multiply the 1 and the 1. That's going to give me a 1 in this space over here. There we go. And now that my 2 fractions have common denominators, how do I add them together?
Add across.
Add across which part?
The
The
numerator.
numerators only, right. So I'll add the 3 and the 1. That's going to give me a 4. What happens to the denominator? Keep it the same. Right? It's the same denomination. It's the same. It's a stack of 3 $5 bills and a stack of 1 $5 bill. You put them together, you have 4 $5 bills. The denomination, the denominator, doesn't change. So there's where the 4/3 came from. Right? This is the longer form explanation of why this trick to convert mixed numbers to fractions actually works. Right? Because we, in the process, reinterpret 1, when we multiply it by 3, we reinterpret it as being 3/3. Then all we have to do is combine those 3/3 with this 1 additional third, which is indicated here, to get us a total of 4. And that gets us from mixed number land over to fraction land. And fraction land is where we do all of our arithmetic and everything else. Sometimes, by the way, these fractions are called improper. They're called improper only when the number in the numerator is larger than the number in the denominator. But there's really nothing to that other than terminology. And I don't even particularly like the terminology because it makes them sound bad somehow, improper fractions. When in fact, they're super good, they're super useful, because they're the way that we'll do arithmetic with these kinds of numbers. Right? We can't really do much with mixed numbers because of this little hidden plus sign in there, which explains how to convert into a fractional form. The question was, okay, if I know how to do arithmetic with fractions, that's one thing. But what happens when the fractions are negative? What happens when they represent a negative number? So there are a couple of examples here where we're going to do some arithmetic with fractions that involve negative quantities in them. Let's take them one at a time. So let's start with this fraction right here. I just want to take it in isolation. 12 divided by negative 20. And my first question to you is this number, 12 over negative 20, it is a single number. Is this number negative or is this number positive? So what are the sign rules? We're going to expand on this in a minute when we talk about sign arithmetic. But what are the sign rules involved when we multiply? Let's start from that. If I multiply two numbers, if one of them is positive and the other one's negative or whatever, how do those sign rules shake out? How do we know when I multiply whether the product of two numbers is positive or negative? Yeah, if I multiply a positive number by a positive number, the product is positive. If I multiply a positive number by a negative number, then it's negative. What about a negative by a negative? Positive, right. Yep, so this is a little sort of schematic for if I multiply two numbers together, it tells me how to get the sign of the product from the sign of each of the two factors. So let's think about 12 over negative 20 for a moment. Right now, this is not a multiplication problem. What does a fraction bar really mean? Division, right. So if we're going to understand whether this number over here is positive or negative, we should try to turn this into a multiplication question instead of division. So let's call this number something. I'm going to call it x. Kind of a prelude to doing algebra later on in the course. If 12 divided by negative 20 is x, how can I reframe that as a multiplication problem? I'll rewrite this again. X equals 12 divided by negative 20. Can I rewrite that as a statement about multiplication instead of division? A simpler example of this might be to say, let's suppose y is 12 divided by 4. So just use some nicer numbers to work with. If I say y is 12 divided by 4, what am I saying that y is? 3. Because somewhere in our memory banks we've remembered that 12 divided by 4 is equal to 3. But why is 12 divided by 4 equal to 3? What multiplication problem is equivalent to this division problem?
4 times 3.
Yes, right. So this is the same thing as saying 3 times 4. You said 4 times 3. I'm going to just flip that around for our purposes. We don't really need to see a difference there, but whatever. 3 times 4 is equal to 12. Right? So if I do that same thing with this division problem, how would this division problem get rewritten as a multiplication problem? So,
X times negative 20 equals 12.
Yes, perfect. X times negative 20 is equal to 12. Right? So there is the equivalent multiplication problem that matches up with this division problem. So my question to you is, based on the signs of these two factors, one of which is unknown, and the sign of the product, what can we say about the sign of x? Is x positive or is x negative? Negative. How do we know? Yeah, right. So this product on the right-hand side, 12, that's a positive product. So that means either it has to be the product of two positive numbers, or it has to be the product of two negative numbers. But since one of the factors, negative 20, is in fact negative, that means that the other factor must be negative as well, because the product is positive. So negative times negative gives us a positive, right? There we go. So x is a negative number. 12 divided by negative 20 is negative. Okay, here's another question. What would happen if I took this negative sign from the 20 and I moved it upstairs instead? Let's try it out. Let's see how that would change our thinking. So now the negative in my division problem is going to move from the divisor to the dividend, negative 12 divided by 20. And if I rearrange into a multiplication problem in the same way we did before, Now this 20 becomes positive, this 12 becomes negative. So I'll write this as negative 12. So now what does that tell me about x? If x satisfies x times 20 is negative 12, then is x positive or is x negative?
Make it negative.
Negative, because?
Negative times positive.
That's right, that's right. So we know the product has to be negative. That means that these two factors have to have opposite signs. Right? So one of them's got to be positive and the other one's got to be negative. And since this one's positive, that means that this one's got to be negative. So we come to the same conclusion about this x when I move the negative sign upstairs, as we did about the same fraction with the negative sign in the denominator. So then my question is, does it matter where we put the negative sign?
No.
It doesn't matter. It doesn't seem to matter. It doesn't matter to the sign of this quantity. It turns out it doesn't matter to the value of this quantity either. So negative 12 divided by 20 is the same thing on the nose as 12 divided by negative 20. And because those two are the same, mathematicians do this a lot, by the way, because they're the same, we end up using an even third different notation to write them most often. Most often we'll take that negative sign and we'll put it out in front of the whole fraction. Because that's, in my mind at least, a clearer signal to the person reading this that this number is a negative number. It's the negative, it's the additive inverse, it's the opposite of the positive number 12 over 20. So all three of those mean the same thing. And what you can do with that, so what you can take home out of this conversation, is that anytime we see a negative sign in or around a fraction, it belongs in exactly one of the following places. We can put it out in the front, as in this one, or we can put it in the denominator, or we can put it in the numerator. But we shouldn't put it in more than one of those two places. This is another common point of confusion. Because if I were to make both the numerator and the denominator negative, then what would happen? Yeah, just take a look at what would happen if I did it with both this negative 12 and this negative 20. Now this multiplication problem has two negatives in it, which means that this 20 would have to have its negative on it. But now that makes x necessarily positive. Right? So it turns out that the same sign chart that goes along with multiplying also goes along with dividing. Right? If I divide a positive by a positive, I get a positive. If I divide a negative by a negative, I get another positive. So if my fraction is negative, that means that its numerator and its denominator should have opposite signs. And which one of the two that we place the negative sign doesn't matter as long as it's only in one of those two places. And if you prefer not to have a choice, it's most convenient for us to put negative signs in the numerator and not in the denominator. Because denominators we generally have to change when we do arithmetic, particularly addition and subtraction. And so to the extent that we can avoid having to change negative quantities, we like to do so. So typically, I like to put the negatives up in the numerator when we start doing arithmetic with fractions that